Hey YouTube, this is Jim Neeb from Jim Neeb Works again. A couple months ago I was watching a video by one of my favorite YouTubers, Robert Cowan. He was showing the effects or the benefits of a spray cooling system on his CNC machine for machining aluminum. And he had a really nice mist buster system. And he was using IPA, and I never thought of using isopropyl alcohol for a coolant before, but it really intrigued me because I cut brass and aluminum periodically on this, but my machine is mainly for woodworking, and so all the traditional oils and cutting lubricants are really messy, and they're fine if metal is your business. You typically set up to, to tolerate you have a mess and you're okay with it. I don't want my MDF spoil board getting all messed up. I don't want oil all over because when it mixes with sawdust, I get a big gooey mess. IPA evaporates completely, very quickly, doesn't leave any residue, doesn't make the wood swell or anything. It's relatively cheap, and I wouldn't have thought it, but it actually works very good as a cutting lubricant. And so I'm going to put a link down below for Robert's video because he did a lot of testing on aluminum to show that it works well. And then there's also some nice articles out on the web. I think it was MIT that did a study on different liquids used as cooling and cutting lubricants. And surprisingly, a lot of them that you don't think of a lubricant or necessarily even for significant cooling really work well. They explain the physics of it a little bit better and everything, but I thought I'd give it a shot on my AVID CNC machine, but I didn't want to go buy a $500 or $400 mist cooling system either. So I'm going to show that you could go buy a few cheap components and make it work really well. My mister is actually a cheap Chinese mist, just the nozzle and mixing valve off of Amazon, and my container to hold the IPA is just simply a rather inexpensive water filter container, and then I kind of combined the two and mounted them on here. So I'm going to do some tests on brass. Robert covered aluminum very well, so I haven't gotten to that yet, but that won't be the subject of this video. I'm going to use an 1/8 inch end mill and do some pocket and routing around basically a cutout of a engraved plaque that I made. So hope you enjoy. Okay, let's go over the components of the cooling system that I installed. So up here above my spindle is my air manifold where I have a couple different connections for different purposes. I have a quick connect out here that I could use for a manual air nozzle, but the main thing I use that for is to connect the air assist nozzle for my laser when I have that attached, and I disconnect the laser when I'm not using it because I want to keep it out of the way of all the dust and dirt from the spindle. So I just have this quick connect attachment there. And then I have two of these flexible nozzles here. This one is a high air volume one that I use like when I'm cutting wood and things that don't need cooling. I just want to evacuate chips. This has a little bit bigger nozzle, and the valve allows for a lot of airflow, so I can really blow on something to keep out of a deep groove or channel that I'm cutting. So I primarily use that for, again, machining wood, especially with when we get the chips up into the air so that the dust collector here can suck that in. I don't have the boot attached right now, but I normally have a boot down here, and so the air nozzle helps get those chips up into the air so it can get sucked out much easier. But the subject of today's video is this little box here. It's the mixer valves for the IPA. So this top valve here is the actual IPA valve, and you can see the little hose coming in there. That goes back to my canister for the fluid, and then this bigger hose coming into this valve, that's for the air pressure itself. So that I can set my air pressure, and then this one with the fluid adjusts the amount of fluid that gets mixed into the stream. And then this here is the nozzle for the jet, and you might think that this is just simply mixed back here and then shot through a normal tube. That's not true. These are actually if I screw this off, you can see it's got a mixer down at the end here. So there's the fluid tube comes down the center of this, so the air is blown inside the plastic tube, but then you can see there's a little fluid tube that comes down to kind of a multi-jet. You can see multiple holes here so it all gets mixed right down at the end, and I think the purpose for that is to keep it liquid. Yet you don't really want this, you don't want fumes, you want kind of a splattering of IPA or whatever coolant you're using. Not, like I said, you don't want it to mix with the air and just have dry fumes coming out, because that doesn't really cool. You really want the liquid to hit the surface. There's papers out there that shows that that liquids on the surface actually help the cutting process to lubricate it and keep chips from sticking, especially on kind of, I would call them gooey or sticky metals like aluminum and brass, keep them from sticking to the bit. But you also want the vaporization to happen right on the bit and the cutting surface, because you get the significant cooling effect from the latent heat of evaporation. So that needs to happen right at the contact points of the metal. So that's why it's designed this way, unlike this one, which just blows air through the end. So then my line here, both my air and my IPA lines just run through my gantry and come out to the end. And right here you'll see mounted to the back of my gantry with just a simple bracket is the container for my IPA. Now, on other videos, I'll put the link in the below the video on YouTube, but you can buy the Mistbuster system. That's like $300 or $400. It's a great system, but I didn't want to spend that much money because I don't cut metal very often on here, so I wanted to see if I could build it cheaper. So this canister is simply a water filter canister that you can buy on Amazon for about 30 bucks. It looks very similar. I don't know if the materials are going to stand up to IPA over time. We'll have to see. And then I just put a one-way check valve on the end here to keep, so it can draw air in, but it can't evaporate out very easily. It's got a very weak spring on this, so it doesn't impede the vacuum effect to draw IPA into the mixer nozzle, but it does kind of back check that evaporation from coming out. And I live in Phoenix, so that would, we get to high temperatures here in the summertime, and that would vaporize pretty quickly if I just left this full. The other thing is this screws off very easily, so between uses I'll probably just dump this back into the main container when I'm not using it. And then this piece here is a jet cooling system, but it's not the kind, it's not a very expensive one. It's just a cheap one I got off Amazon. I think that was $30 or $40 too. There's a few different styles of those. So that's really all there is to it, is this plus the canister. I think I maybe total spent $70 or $80 on this. So now let's give it a try, cutting this brass with a 1/8 inch end mill. Now this isn't a specific brass cutting end mill or anything. I don't know if you can see very well. It's a 2 mil or 2 flute end mill, 1/8 inch. A single flute would probably be better for this because it'd have a little more stiffness than the 2 flute, and I could push it harder. These I find in brass, I only cut about 20 thousandths deep, and I run about 20 inches per minute. I get a little cleaner cuts if I run a little faster, but the 2 flute, if it gums up at all, then it can't cut cleanly, and it'll snap the bit off pretty easily. So I'm hoping this cooling system does a better job of keeping that bit cool and more importantly clean from any brass buildup on the tip. If that happens, this thing will cut all day long nicely at this feed rate and maybe even faster. So we'll see how this works. Okay, I just turned my air control solenoid on. My machine, I'm going to turn my air valve on here. And it takes, to suck it all the way through the line, it actually worked pretty well. Pretty good vacuum. You can see it's shooting out kind of globs of IPA. That's more than I want. So I'm going to dial this back a little bit. Turn up the air so it's sucking pretty good. I just want a little bit of IPA come out. And you can see it comes out of my hand and evaporates pretty quickly, but that'll keep the surface wet and cooling while it's cutting, and it's using a very small amount of IPA. The reason I was interested in using IPA is my machine is primarily a wood cutting machine. I have a wood spoil board. I don't want normal cutting and / cooling oils all over the place that just make a big mess in my shop. I cut aluminum and brass fairly infrequently, so I want something that evaporates and leaves a dry setup when it's all done. You know, doesn't make my whole system turn into a big gooey mess like a metal machining system would normally. So that's what my desire is here. It might not be as optimum as those other cleaning fluids, but I'm hoping that it's enough of an improvement to make it worth the work and the $80 I spent on this. Okay, now all the crosshatch is done, so it just runs a perimeter around everything to give it a nice crisp edge. This goes pretty quick. The rest, the crosshatch I did at a 5,000 step over, which gives a pretty nice background fill without looking stripy. And I don't do a crosshatch. It's not really necessary with this amount of step over. Even though you can do it, it's not really hard on the diamond since brass is pretty soft. You could see though now when it does this perimeter, it really leaves a nice defined edge to the part that is not crosshatch filled. So this looks really nice. Okay, we've got the engraving done now, so we're to the point of the real point of this video, which is to show cutting the brass with a 1/8 inch end mill and see how the mist cooling system here works and improves that. So I'm going to put my bit in and fire that up, and we'll see how that cuts. Just wanted to mention too that this piece of brass plate is mounted down just with some double-sided carpet tape. You can see it here sticking out, so I find that holds down very well, and so I can do that on top of the sacrificial piece of MDF. It'll cut through. The carpet tape isn't great for cutting into it, tends to gum the bits up a little bit, but I'm hoping that the IPA helps keep the bit clean from that, and it really only happens on the last pass, which I'm taking pretty light passes anyway, so it's kind of only a problem at the end, but I haven't noticed any negative effects of the gumming either. I don't run it, it doesn't get that hot or anything, and it doesn't seem to really impede the cutting, but again, it's only happening at the very end.
Okay, on the last cutting of this, I messed up and didn't turn on my video recording properly, so I missed the cutting action all the way around this plaque. So I'm just going to say that this turned out very clean compared to the previous ones I had done without mist cooling. But to show and demonstrate it, I added a quick pocketing tool path to show it cutting on that, just to demonstrate that, for it, so you can see it actually cutting. Um, Before, I used to get a pretty big burr along the top edge, and a lot more deflection. And the really bad thing that happened was if I pushed it at all, ran a little bit too fast or a little bit too slow, it would get hot and the brass would build up on the tip. And once the bit has, any brass buildup at all, it's basically not sharp. It's just rubbing, and then it just quickly goes downhill and snaps off the bit. This picture I know looks pretty rough around the edges. That's not the pieces of metal that are sticking out from the cut. They're actually pieces, kind of cut pieces that are stuck on because of the goo of the tape underneath. The tape, once you make the last pass, that carpet tape kind of mixes with all the cut off brass or metal pieces and makes a little bit of a mess. So I'm going to make a pocketing path and not cut through the brass, so you can just see the pure cut in the metal. And also, when I say this is clean, it's not relative to a super precision CNC milling machine. Keep in mind, this is a CNC router and a 2-flute 1/8 inch wood cutting bit. This is not, going to compare to some, great mill. When I say it's clean, it's compared to what I was doing dry before. So this is, it's a significant improvement from what I had before. And for the kind of work I do, this is perfect. I don't need to have super shiny surfaces with no machine marks, but this can easily be cleaned up with a file or a brush around the edges.
Okay, hopefully you can see, if we can get this to focus right. This is extremely clean. I purposely didn't cut through this time so that the goo from the carpet tape would show. This way you get to just see the machining part. So I cut a 50 thousandths deep pocket into this. I was running 12,000 RPM on the spindle, 20 inches per minute, 20 thousandths cut, and it was a climb cut. So you can see I'm extremely happy with this. I definitely couldn't cut this clean before without the lubricant from the mist lubricant / cooling. It tended to gum up the tip and start to kind of get gooey. You see a big burr develop on the top edge, and here on this one it is just super clean. So I think I want to say thanks to Robert Cowan for his suggestion. He has, as I mentioned before, a great video on the effects of the IPA cooling using the mist buster system on aluminum. He did some fly cutter or top cleaning of some pieces of aluminum and did a lot of extensive testing, so I recommend going and viewing that video. But I just really wanted to show with this that you could build that a little cheaper if you wanted. Again, I spent about $80 on mine, just off Amazon for the mist sprayer itself, and then the container in the back there it was a water filter container. But this works really good. I don't have any, it's only been a minute or two. It's completely dry. I don't have, oil residue and stuff because it's IP. It evaporates very quickly. I thought about the fire hazard of IPA and discussed it with Robert a little bit too, and did some research online. IPA, it doesn't evaporate, or I shouldn't say it's not as volatile as like gasoline or something. It takes a pretty good spark and pretty good density. But the thing is, I've got this air coming through here at about 1,200 cubic feet a minute. So the density of actual IPA fumes relative to the air is extremely low. I opened up my, I have a dust collector canister in the back here. You can see it. I opened that up right after the machining, and there was no hint of IPA smell in there whatsoever. So I know this is keeping the fumes at a very low density and extracting it. In my case, mine vents to the outside. I definitely wouldn't recommend doing this in a small enclosed room. So you have to think about that. But in my case, I have a big open garage, and I've got very good dust collection on the system anyway, so I don't think that's a concern at all. So anyway, I think this is a good option for people to think about when they're not doing a lot of metal machining and they don't want a big messy system using the traditional metal coolants for machining. This really makes a significant improvement on brass in my experience, and according to Robert's testing, did a lot of improvement on aluminum as well. And those are two materials that are machined nicely on a CNC router like this, but traditionally are a little hard to machine because they don't cut as clean. They tend to get, if the bits start to get hot, the material builds up on this. Really seems to solve my problem. So anyway, if you have any comments or questions, put them in the comments down below, and I will answer you. Thank you.